Hi everyone, in this video we are going to learn about the setting reaction of alginate impression material and its practical importance. Essentially, the powder of alginate contains soluble salts of sodium or potassium alginic acid, which is schematically represented here. This is one chain of alginic acid. This is another chain of alginic acid. Alginic acid is nothing but an organic polymer. In fact, it's a copolymer of mannuronic acid and buluronic acid, and this is obtained from a marine plant. And this particular alginic acid that we have represented here is a sodium salt of alginic acid. So you can see the presence of a group of sodium as a pendant group here. The next ingredient, an important ingredient which takes part directly in the setting reaction of alginate, is calcium sulfate dihydrate, which is nothing but your gypsum. So this is your calcium sulfate which acts as a reactor. So when you mix these ingredients together with water, what will happen is the calcium sulfate gets dissolved in water, gets dissociated into its respective ions. This has limited solubility in water, so you can say that only few of the calcium sulfate ions have got into water. As we can see that calcium, let me show here, calcium is a divalent ion. This is going to knock out and replace two of these monovalent sodium ions, and it is going to take their position like this. When this happens, there is going to be a cross-linking between these two adjacent chains of your alginic acid, and this is how a soluble salt of sodium alginate gets converted into insoluble calcium alginate. And this is exactly how the setting reaction happens in your alginate. But the story doesn't end over here, because this reaction is very fast that you won't get enough of working time. What is working time is, it is the time that is required to manipulate your material, load the tray, and then comfortably place it in the patient's mouth. Alright. So when this reaction happens so rapidly, there won't be any adequate working time available. So for that reason, a third ingredient has been added, and that is your trisodium phosphate, which acts as a retarder. Let me bring in some trisodium phosphate and start all over again. Okay, so as I have told you, the trisodium phosphate acts as a retarder. So we are again starting all over. This calcium, the reaction has not occurred. So this is the sodium salt of alginic acid. Alright. Now again, you have mixed all of these ingredients together in water. So the calcium sulfate as well as sodium phosphate, these are going to dissolve in water and get disassociated into their respective ions like this. Alright. Now again, a very interesting phenomenon happens here. Calcium, instead of going and knocking out those two sodium monovalent ions, it preferentially comes and binds with calcium phosphate. Same here, the second one doesn't go here, comes here, preferentially acts with phosphate ion and forms calcium phosphate. Sodium goes and it binds with the sulfate ions and it forms sodium sulfate. Now, till all of these phosphate ions have been used up, the calcium is not going over here, the setting reaction doesn't start, so you have an extended working time. When all of this phosphate has been used up, then this dissociates and the calcium goes and it knocks these sodium ions, and then it takes their position, and then the cross-linking between these chains happen, and this is how your alginate is going to set in the end. Alright, this is all about the total setting reaction that is seen in your alginate. And apart from these three main important ingredients which take a direct part or role in the setting reaction of alginate, there are other ingredients which have been added, and that is the diatomaceous earth, which acts as a filler, and it is present in a larger quantity, and that is in 60%, and this increases the mechanical property of your impression material, and most specifically it increases the gel strength. Then you have in your material potassium sulfate or potassium zinc fluoride. These act as gypsum hardeners. Now, why do you need a gypsum hardener in your alginate impression material? Because you already know alginate is an hydrocolloid, and colloids are retarders for gypsum products. So when after making your impression, when you're pouring your cast with your gypsum product, you might get a chalky or a soft surface on the cast. In order to avoid that, you're going to add gypsum hardener. Alright, you have flavoring agents in your impression material in order to improve the taste. If you're using a chromatic alginate, then you have some color changing agents. This is all about the composition of your alginate and the setting reaction. And let's dive into knowing what is the practical application of all of this. So with this reaction, we have understood that the calcium or the source of calcium is needed for the setting to occur. So in any of the reasons, if the source of calcium is increased, your material is going to set faster. Let's see what are those reasons when you would see an increase in the concentration of or the source of calcium. Say for example, when you're mixing your alginate impression material, you have used your tap water, and you stay in an area where you have hard water which contains a lot of minerals, and those minerals even contain calcium. So again, in that case, you're increasing the source of calcium in your mix, so the material would set faster. Unless and until you know the reason or the process of setting, you wouldn't understand you're going wrong there. Alright. The point number 2, if you're a researcher and working on alginate, never use any kind of water that has got mineral in it. That means you're supposed to use demineralized water which doesn't have any mineral content in it. Otherwise, you will be getting false reports. The third and most important point is, if you have used a bowl to mix your alginate which has got pre-mixed traces of gypsum, that means you have not cleaned the bowl properly. So we already have seen your gypsum is nothing but calcium sulfate dihydrate. Again, it's going to act as a source of calcium, so your material is going to set really fast and you wouldn't get enough of working time. Alright, so I hope I have explained the setting reaction of alginate in most simplest form as possible. Yeah, thank you so much for watching this video.